Hello, and welcome to another episode of Cooking with Unity, episode 24. As of this episode, we'll have over 24 hours of content. That's exciting. Alright, I don't sound excited, but it's exciting. There, now I sound excited. Alright, where's my screen? There we go. So, yay, 24. So, today we're going to be doing a dual stick shooter, and I'm a little afraid this is going to be kind of similar to what we did with asteroids, but I promise you we'll make it more interesting than asteroids. Dual stick shooters, they're pretty commonplace now. As soon as people realized that there were two analog sticks on controllers, they were like, oh wait, we could do the Robotron thing and do dual stick shooters. So for theming, obviously I don't do theming on this show, so it's going to be a whole bunch of like cubes killing each other. But I'm going to be drawing inspiration in particular from Smash TV. So it's not just going to be a single static screen. I kind of want to have it where there's a screen, like it is a static screen with regards to individual gameplay, but then it has some progression to like new screens and new obstacles and stuff. And we'll see where we get from that. We're going to start basic and kind of build on that. So let's get started here. So let's first off, how are we going to set this up? So let's go ahead and put a plane. Yeah, let's create a backdrop. We don't need a backdrop. Let's just get some guys moving around first. So let's make a cube. Is that what we want our player to be? Now let's make our player a sphere. We'll have all of the enemies be angular. Alright, so we're going to be a sphere this time. Put it at 0, 0, 0 for right now. And let's just get the sphere moving and shooting. And then we'll work from there. So I'm going to create a bullet for the sphere. What's a good bullet? We'll just start with cubes for right now, just because we can do a lot of cubes without too much hurt on any computer. Spheres are actually a little bit expensive, honestly, the way that they have them set up in Unity. As a matter of fact, let's find out just how expensive. Yeah, we've already got 772 tries. If we get rid of our our sphere. Wait, we're not at 772. That was a lie. Alright, we're at 12 tries. If we add a sphere, let's see what that puts us at. Yeah, 772. Yeah, that's a lot compared to 12. So, yeah, good that we're just going to make our main character a sphere. That's the main reason I'm not more varied with the objects I use. I use a lot of cubes just because the spheres are expensive, and for no real good reason, but just the built-in stuff. And we're just doing prototyping, so I'm not usually that worried about performance, but whatever. So we're going to call this cube a bullet, and we're going to call the sphere a player. And I'm going to go ahead and prefab both of those and delete the bullet. And we're going to create a script called Dual Stick Shooter. So first off, let's go into our project settings input and see what we've got for axes. So we've got a horizontal axis, we've got a vertical axis. I'm going to create mouse X, mouse Y. Oh, there's another horizontal and vertical. What are these? Oh, those are joystick. Okay, so these are the joystick equivalents of those. Alright, well, let's create... I'm going to remove the fire ones because we don't actually need these. I'm going to rename them and use them as our horizontal and vertical fire axis. Fire horizontal and fire vertical. And let's set these up somewhat similarly. So I'm going to make it so we've got alt buttons here already. So I'm going to get rid of the... Actually, I'm just going to make this A and D. and down S and W, and then we're going to set up the horizontal as negative for left. How do we do left? Probably should have been paying attention. Actually, let's undo some of this. Yeah, up. Okay, yeah, that's probably simple enough. So, left, right, and for fire vertical, it's down, up. Whoops. Down, up. And we actually got to clear the secondary buttons in all cases. Wait, A, yeah, that's right. A is to the left of D. Alright. Whoops. Let me go back in there and just make sure everything else is pretty clean. Sensitivity 3. Sensitivity 1000. Yeah, let's change these to be similar. So sensitivity 3, gravity. I don't know what that actually means in this context, but snap. What do they have that for the... that's just because it's using buttons. Yeah, we'll use snap, whatever. As I said, I'm just kind of duplicating what we've got up there already. That looks pretty good. Alright, so now we've got our axes set up. So what this is for is we're going to be, I'm going to save our level. This is test level. And now we can do our little dual stick shooter script. So we're going to attach this to our player. So what do we need in a dual stick shooter? So let's look at this. So I want to have multiple weapon power-ups in this one. So in the past, what we've been doing is in the script that spawns the projectiles themselves, we typically apply a force to the projectile. And the projectiles are just dumbfire. They're just objects that have a certain amount of power, or a certain they don't have power or anything. They just are objects, and then we apply a force to them to move them. Do I want to do that or this way, or maybe I do want to keep that? Yeah, let's keep that for right now. We may change it later. The reason I'm thinking about this in advance right now is because if we have multiple weapons, we may want them to behave differently, and so not all weapons we're going to want to just project out at whatever rate. Yeah, I am going to actually do it that way. I'm going to do it on a per weapon basis. So the player will not have any information about their base weapon stuff. That will be determined by the weapons themselves or the bullets that they are associated with them. So let's just worry about the movement part first. So public float move speed, public float. There's a few things I need to think about how we're going to actually do this. I may do it in a simple way first, and then we'll modify it later. So I'm going to put the shoot delay here. Public float shoot delay. Anything else we need? Probably not. That'll work for right now. So all we're going to do is in our update loop, we're going to move the player around based on their move speed and based on the controls that are being pressed. So this is pretty simple because what we're going to be doing is we're going to be accessing our get access stuff. So input.getAccess, and then we give them a string axis name. So let's go horizontal first. So what this returns is a number between -1 and 1. And -1 is the furthest to the left as you can go, and +1 is furthest right. On the keyboard, -1 is left is just going to be -1 always. We're not going to make assumptions like that, so this could be converted to an actual joystick. But as a matter of fact, I probably will go back into input and actually add the mapping so that we can do a proper joystick thing. But for right now, it's going to look very, very digital because it is. So what we're going to do is we're going to basically add together our two axes and then use that total to determine the direction that we're moving. And we can also, and that'll implicitly give us a speed too. So all we're going to do is move vector 3 move direction equals input.getAxis horizontal plus input.getAxis vertical. So this will give us a vector that describes our movement direction. And so our position, so transform dot position plus equals move direction times move speed. Oh, times time dot delta time. So let's make the move speed 1 equal 1.0 f, and let's make the shoot delay equal 0.5 f for right now. Let's make it shorter than that, 0.2 f. Fire 5 a second, that sounds about right for a nice little rapid fire. And let's just start with this and see if it works real quick. So this should do just X and Y, hopefully. We'll find out what actually happens. Cannot convert float to... Oh, yeah, these returns floats. Yeah, that doesn't return vectors at all. So, what will this be then? It'll be vector 3 dot, new vector 3. X would be the horizontal, Y would be the vertical, and Z will be 0. So let's see if this works now. Transform does not exist in the current context. Transform, okay, missed an S. Alright, so I'm going to put a directional light in. So it compiled that time. Now let's actually see if it works. Let's attach this to our player and hit play. And I hit the buttons and nothing happens. Move speed, shoot delay. I'm going to put the camera at Y0 so that doesn't confuse me later. So I click here and I move, I press the directions and nothing happens. So what does that mean? Update is called once per frame. Transform dot position plus equals move direction times move speed times time dot delta time. That should work. Set the move speed to 100 and see if anything's different. Nothing. Oh, there we go. I was using the arrow keys, but as you remember, we actually changed it to use WASD for the movement. So that was the problem. I was hitting the arrow keys and they weren't doing anything. So There we go, and that's sluggish. We don't want that. We want something a little bit less awful. 5 speed. Okay, there is some drift to it, even though it says snap. So I don't know what snap actually does. You can see I can kind of smoothly move in a circle, even though that's not really possible in a digital environment. But that'll work to our advantage anyway. That's kind of nice. Alright, so now let's actually make it shoot. We're just going to do it in a very simple way first, and then we'll modify it later to be more robust. So public game object bullet. And what else are we going to do? Public game object bullet. And then we're going to make it work. So vector 3, public float, shoot, bullet speed. So shoot direction will be very similar to what we have here. We're going to just copy this line, and we're going to say fire horizontal and fire vertical. That corresponds to what we changed earlier. And then we're going to perform an instantiate call. So instantiate bullet transform.position. Bullet dot transform dot rotation. So what do we got here? Get access fire vertical. All right, we want to actually normalize it in this case. So normalized. The reason being is we don't want our bullets to be based on how far you're tilting the stick. We just care about the direction of the stick. So if we normalize it, we basically just get the outside edge of the stick. So so instantiate bullet transform position. All right, so we need to actually get the results of this. So game object bullet instance equals instantiate as game object, and then we will do bullet instance dot rigid body dot add force, and we're just going to do shoot direction times bullet speed. I'm just going to say force mode velocity change. What that means is it will ignore the, I think velocity change ignores the mass of the object and just basically sets the velocity to whatever input we give it. So I really should say bullet velocity, but same difference in this case. I'm going to set it to 1.0f by default, though, even though I think that's mega low. So I'm going to reset this real quick so we get the... Wait, we didn't... Oh, I didn't save that. And now we're going to... What else are we going to do? Oh yeah, we have to have a shoot delay. So this would just always be shooting forever and always. So we need to figure out when we should be shooting. So that would be if we're holding any direction whatsoever. So if input dot get axis fire horizontal does not equal 0.0f. So if it doesn't equal and the other one doesn't equal, no, or the other one doesn't equal, or get access, get axis or axis. I've been playing too much PlanetSide. Does not equal 0.0f. So if either of these is not 0, we'll do this stuff. Though we need to have a shoot delay. So how are we going to do that real quick? If these and can shoot. Public bool can shoot equals true. Can shoot equals false. And what are we going to do? Maybe I should do the fancy enumerator trick. Nah, I don't know how to do that really. So I am gonna do a coroutine, but there's a way you can basically set up the update loop as a coroutine. I think maybe that's one of the exceptions, but yeah, I'm not gonna do that right now. So can shoot equals false, and we will invoke. We'll just do an invoke. Actually, that's a lot easier. Invoke shoot delay. Shoot delay. And then we're going to create this function void shoot delay. And all this is going to do is set can shoot equals true. So in theory, we should have basic movement and shooting now. So I can move around. And an unsigned reference, unassigned reference exception. So we're going to throw the bullet in here. We're going to hit play. And so now, yeah, that's not working as well as painting cubes. Yeah, that's a lot of cubes. Only 3 draw calls, though. Alright, so obviously that's not working. Oh, no rigid body. Alright, that makes sense. So we're going to attach a rigid body to this. We're going to hit play. Oh, and they're colliding with themselves and the cube. And why is it still shooting so fast? Looks cool. And it's shooting into the scene now, too. That's great. Okay, so that's just interpenetration issues, but combined with the fact that for whatever reason, even though can shoot should be set to false, I'm able to shoot pretty much immediately again. It does look cool, actually. It looks even cooler at the 60 frames per second, but yeah, my bandwidth just can't send that right now. I really hope I can get an updated... Like, I hope in the future Bend has better broadband so that we can do cooler stuff on the show. Like, actually show more of what's going on. Might just have to move sometime. Though I'm not just going to move for this show. Invoke shoot delay if and can shoot. Can shoot equals false. Invoke shoot delay with shoot delay. So why is that firing off as quickly as it is? Okay, let's see, if I set the shoot delay higher. Yeah, that's definitely ignoring whatever that shoot delay is. It's setting can't shoot default just because I made it a public variable so we can actually see that that part's working. But it doesn't seem to be actually checking to see if it can shoot. Oh, can shoot true. And then can shoot. Oh, got it. Got to put these in parentheses because this whole thing and this thing, as opposed to whatever it was doing before. This will probably fix it. Okay, that definitely fixed the shooting rate problem. Alright, so now we just need to fix the other problem. So first of all, let's make our bullets not ridiculously large. Let's make them ridiculously small instead. Actually, let's let's make them square cubes for right now, though I'm going to probably play with that in a second here. So we've got cubes. We're going to try shooting again. Oh, they've got gravity. That's another problem. Let's not do that. Alright, so they're still interpenetrating and hitting each other and ending up going into another dimension. So let's make it so our bullets cannot hit each other. So let's work on our layers here. So add layer, tags, no, not tags. So let's do player, bullet. And then let's go to project settings, physics. And we're going to make bullets not collide with each other. And actually, I'm going to change that slightly. I'm going to go back into that list again. Where is that? Tags, here it is. I'm going to call them player bullets. We're going to make it so player bullets can never collide with the player, even if you manage to do it. So, project settings, physics. So, player bullets should not collide with player bullets. Player bullets should not collide with the player. That should do it. So now if we hit play... Oh, still doesn't do it because our bullets are not actually on that layer. So player bullets and player we want to have on player. And I'm going to go ahead and apply this to the prefab, and we're going to hit play again. This time it's going to work. And it does. So we can shoot up, we can shoot right, we can kind of rotate it through, and the bullets are going way too slow. But yeah, we've got the basics in there. So let's up the bullet speed to 50, and let's up our move speed to 3 again. It's a little too fast. Let's go for 25. Still kind of feels fast. 10. Yeah, that works. And let's lower the shoot delay so we get a little bit more. Yeah, that's feeling real good on my end. Alright, so 310.1. 310.1. Apply. Company meeting. Where are you located, Retronic Games? Retronic Games is in channel, and he just said time for our company meeting. I guess you're not in the States? Or are you just working real late? Oh, good. I'm glad that you're working on a dual stick shooter, so this will probably help for a few things. We haven't really gotten into this yet, though. Hopefully it'll be fun. Alright. Wow, it's 8:45 already. Oh, yeah, that's right. I started at 8:15, so I can go for another 30 minutes. Alright, I was I was going to be like, wow, that was fast. That seemed faster than 45 minutes. And it was. It was only 30 minutes. So first of all, I'm going to make can shoot not a public. It's really meant to be private. But it was good for debugging. Sometimes that's useful just to make your private stuff public so you can see what's going on in the inspector. Alright, so moving my little dude around. We got shooting, we got moving. That's great. So, what next? Let's put some enemies in. Let's make some enemies do some stuff. So we're gonna need an enemy. What's gonna be our enemy? We're gonna go for evil red cubes. We've never done that before on this show. So we're gonna do my standard create material red. I'm gonna throw it on our cube. We're gonna call this enemy. Actually, I'm gonna call this one fodder. This is gonna be the enemy that tries to touch you to kill you. So, fodder enemy. We'll have fancier enemies later. This will probably be a good example for some AI stuff, hopefully. We'll try to make some interesting behaviors at the very least. So, fodder enemy, I'm going to go ahead and delete him from the scene. I'm going to zero out his position. Oh yeah, I wanted to do something real quick, actually. I want to make the... I'm going to make it so that the bullets can be a little fancier. So right now we're shooting cubes. I'm going to actually change this to not a cube. I'm going to make it a long cube. So first of all, we're just going to see how that looks. So now I'm shooting these posts that are out into nowhere, but that doesn't really help us and doesn't look that much better. As a matter of fact, it kind of looks dumb. So, but what I want to do is I want to actually make them shoot out, and so that they go in that direction. So I'm going to go into my dual stick shooter script here, and just because I want a little bit more variety than just cube, we're going to make it so that they rotate in the direction that they're going to go. So transform rotation. So we're not going to use transform rotation. We're going to use quaternion dot look rotation, and then all we have to give it is our shoot direction. And that should make it so that these will now angle out the way we want. Sweet. They're a little long. I'm going to make them a little bit shorter, but now we've got kind of a little bit more of a Vulcan style thing. And it's more interesting to look at than cubes. And this could be any shape you want. Like, you could just basically set this up as whatever kind of thing that you wanted to shoot out of your sphere here. Let's make them 0.75. Yeah, that looks pretty good. So this would allow you to, you know how most games, the bullets have like a chevron shape or something more visually interesting than just a cube or something. But you always want it to be pointed in the right direction. This is a real easy way to do it. The only thing that you have to make sure of is you just have to make sure that whatever direction is pointing in the Z direction. The reason you need that is because look rotation assumes that the vector that you want it to be looking at is in the Z direction of that object. So it will point the Z direction of that object in whatever direction that you give it. And so you always want your objects to, it's just a good general practice on a lot of engines actually, to have it be Z forward, or, well, sorry, a lot of engines. Engines that use Z as depth, yes, you want Z forward. Engines that use Y as depth, X as depth, what one do they, I guess they use Y as it sometimes. Then you'll want Y forward in that case, but this is Unity, we do Z forward, and it makes more sense to me anyway, because I kind of think of the progression of 3D from a 2D screen where X and Y represents the screen and Z added in where Z represents the depth. So, and that's how Unity operates. So we've got this going. That's kind of interesting. So let's get our enemies doing stuff. So all these guys are going to do is follow player. So follow player. So we're going to open this up. And we'll just have a public float speed, then update. So public float speed, update. So we just need to figure out where the player is and go in his direction. So in this case, vector 3 move direction. We're just going to use the same type of variable names, and it's going to be pretty much the exact same code, just a different definition for the move direction. So the move direction is going to be our player position. So we need to get our player position first. Easiest way to do that would be with a reference, and we're going to just grab this reference dynamically, so we're going to do it by tag. So I'm going to go ahead and tag the player, add tag. So in tags, we're going to put player. I don't think you can do it by layer for the game, finding game objects and stuff, which is fine. So because player, you'll commonly do this, where you'll have a layer and a tag this name the same thing, and you use them for the same type of objects. But that's what we're doing here. So we get the player, which is game object dot find game object with tag player in quotes dot transform dot position. So that position minus our position, so the enemy's position, transform dot position. And then we take this whole thing and normalize it. And that gets our move direction. And then we do the same thing as before. We do transform.position plus equals move direction times speed times time.delta time. And let's make the default speed something meaningful. We'll just do 1.0. Again, and we'll save, throw this on our fodder enemy, and let's just throw a fodder enemy in the scene and see how it operates. I don't want it to be in the Z direction. Where am I looking? Okay, there we go. This is actually how the scene looks. Alright, so if we hit play, so we've got our fodder enemy and it's following our position at a set speed. Excellent. That was easy enough to set up. That kind of looks cool with the zero gravity bouncing off of things there. He's invincible. It's impossible to kill him. Oh no, he's touched me. And it does nothing because I don't even have a rigid body. And we haven't done any code or anything for that. So, alright. So, before I forget, I'm going to go ahead and make it so destroy on invisible. We're going to throw this on our game objects here. So, void on became invisible. Became invisible, destroy game object. Whoops, wrong type of game object. Game object. There we go. I'm just going to throw this on our bullets so that we don't pile up quite as many bullets in the list there. So yeah, they only exist while they're on the screen. I can get one to exist a long time just by doing that. Yeah. I love Unity. This is too fun. Why is it that... oh, I see. It keeps going after I press it for a while because of the... because of whatever delays in the input stuff. So I'm going to look at our input again real quick. I'm just curious how this stuff actually works. So it says snap. I don't know what snap means. Sensitivity, gravity. Yeah, I don't know. Whatever. Alright, so we have an enemy. It can follow us. Let's make a spawner for that enemy. So we're going to just delete this guy from the scene. And we're going to create a empty game object in the game object menu up here, not down here. And we're going to... Do we want this to be an enemy manager, or do we want this just to be a straight-up spawner? Let's just make it a straight-up spawner. Enemy spawner. Alright, and we're going to create a script. And we're going to go into our script. Look in game object enemy type, public float spawn radius. So all this is going to do, oh yeah, and spawn rate. And I'm going to put a bool in here with the expectation that we're going to be defaulting it to yes. Build pool spawn at spawn on shell spawn on yeah, whatever. I'll just assume that because I can't think of a good descriptor for it. So instead of what we've done in the past where we spawn things kind of randomly inside of us, the reason I'm doing that is because it's kind of a standard spawn strategy for these type of games. Enemies just kind of coming in a circle and then coming towards the center. This is not going to be our only enemy spawn type. We're going to try and play around with that when we add more levels and stuff, but this is going to be a good initial test and get us some gameplay that basically works by the end of the night here. So, spawn rate. So all we're going to do is we're going to set the spawn rate here to we're just going to invoke. I'm not going to do invoke repeating this time. I like doing invoke commands within the new functions because it means that we can real-time adjust. It's something that I kind of figured out while we were doing this show. If we do invoke repeating, it'll just keep doing the spawn rate. But then, if you change it while it's running, you won't get a change. This will at least allow us to make the change, and the next time it spawns, the change will apply. So, we're going to do spawn enemy and spawn rate. Actually, I should say delay. Equals 1.0 f, spawn radius equals, well, let's do 10.0 f as a default. So we're not going to need an update function. We're just going to do void spawn enemy, and we're going to instantiate. Actually, let's figure out the spawn position first. Vector 3 spawn position equals. We're going to use the enemy spawner's transform. So transform dot position plus random dot. So they got inside unit circle, inside unit sphere. We're going to do inside unit circle. We're going to cast this to a vector 3 and we're going to normalize it. So the reason I'm normalizing it is this will make it go to the outside. Inside the unit circle will be anywhere inside of it. Normalized will, by definition, be the outside of the circle. And then we multiply in our spawn radius. And then we're going to actually invoke our instantiate command, spawn position, and object. Enemy type, spawn position, and what else? Enemy type, spawn position. Oh yeah, the rotation. Enemy type dot rotation dot transform dot rotation. What is it? Oh, there's not enough. It's not that. Now we don't have to do anything with it afterwards. That should be the whole of the script there. Oh wait, yeah, we want to invoke this again with our new spawn delay. So now if we throw this on our enemy spawner, now I'm going to add one more thing. I'm going to go in here, void on GUI, gizmos.draw wire sphere. The center would be transform.position, and the radius will be spawn radius. So now we'll be able to tell, oh, we don't want a sphere though, we want a circle. Do they have draw circle? Gizmos.draw sphere, icon, line, frustrum. Yeah, they don't have circle. Alright, well, we'll do just draw wire sphere for right now. And actually, let's do it on GUI selected so it doesn't clutter our display. So now if we go in here and we select the enemy spawner, as I said, if we go in here and select... Oh, players already registered. I guess there was already a built-in player tag. Sorry about that. Let's actually look at our player and make sure he's tagged right now. Okay, he is. Oh. Did I... Okay, I did attach it. Why is the on GUI stuff not working? Oh, not on GUI. On draw gizmos selected. It's getting my brain warped. So now if there's our spawn radius. Unfortunately, it's a full radius instead of a circle, but just pretend it's that circle there. So we're going to set up our enemy spawner to have an enemy. So we're going to put fodder enemy in the enemy type, and we're going to hit play. And hopefully, yep, there comes some enemies from the sides of the screen. Oh no, they're coming in. They're headed right for us. Alright, so we have the basic trappings of a dual stick shooter here. So now let's get some basic collision stuff working. Let's do our classic stuff. C# script gib on collide, and this will be we'll be attaching this to our fodder enemy. And what are we going to do here? So public game object array gibs public game. Let's just do gib and public int amount. And do we want anything else? No, we'll just use the physics tags to make things collide or not. So all we're going to do here is, we don't need either of these. Void on collision enter. Instantiate for I int I equals 0. I is less than amount I plus plus standard for loop. Instantiate gib. Position is transform dot position, and gib dot rotation, transform dot rotation. And we're going to want to actually make them explode out a little bit. So public float spawn radius public float explosion. Actually, let's do spawn radius, explosion radius, and float explosion force. So game object gib instance equals instantiate as game object gib instance dot rigid body dot add explosion force. Explosion force transform dot position explosion radius. We've written this 400 times. I really should just have this as a script that we don't have to go over anymore. But sometimes going over it helps, and I do it a little differently every time. So maybe that helps too, or maybe that's just horrible. I'm going to do spawn radius of 0.5 f, explosion radius of 1, and explosion force of 500 to start. Equals. So we're not using the spawn radius. Just let's do that real quick. So transfer dot position. Let's make a vector 3 spawn position equals transform dot position plus random dot. Let's do on unit sphere. Plus random on unit sphere. Oh, times spawn radius. And yeah, that should do it. Oh, in amount, let's make this 10 by default. So now we go over here to our fodder enemy, and we need some, make them spawn into bullets. Why not? Now we need a gib. I'm just gonna duplicate this bullet thing. I'm gonna call this gib. We're going to destroy an invisible. That's good. We're just gonna throw red on it, and we're going to make it actually point 2 in all directions. Actually, let's make it point 1 in all directions. And now we go to our fodder enemy, we throw the gib in our game object, and we hit play. Oh goodness, something bad happened. Yep, something bad happened. Well, we haven't saved in a while, but luckily our level is not complicated in any way, shape, or form. Obviously, I messed something up in the code. We'll figure that out in a second here. So I'm going to force quit this. Hopefully you guys could hear me during that. Had a minor issue. Probably screwed up something in the script. So let's see what happens here. So, cooking with Unity, open project. I think maybe I dragged in the wrong thing. Maybe that's what happened. So let's open up our test level, see what's in there. We need to create an enemy spawner again. So create empty enemy spawner. Again, save early and often. Don't do like me. Throw enemy spawner on here. And we throw our fodder enemy here. Let's see if it kind of works. I'm not going to shoot at them just yet. Okay, it's working. I do need to put a light in the scene. And I want to make sure that the player is at 0. Yeah, it's really close to 0, but... Alright, so that's working. So let's see what we got for the fodder enemy. It's... Okay, it didn't save the gib type, so we're going to call this... gib. Is there anything special about this gib? No. Alright, so let's throw it on here. Let's look at my code. Let's see, is there anything that would have caused a crash like that? Gib on collide. On collision enter. Oh! Yeah. Forgot something. We want to destroy our game object. So what was happening is it was colliding a lot, and it was just spewing gibs, and the gibs were colliding with it, which was causing it to spew more gibs, and it was just all unhappy. There we go. Oh. Wait, what? What's going on? Alright, so that was interesting. I guess it didn't save this part. We also want these to be red. That being said, that doesn't really explain why. I guess we'll make sure that they have their own layer. Add layer gives. Actually, I'm just going to call this. Yeah, we'll just call it gibs for now. So we're going to put our gibs on the gib layer. And gibs shouldn't collide with anything. So, project settings, physics, gibs just shouldn't collide at all. Let's see how this looks. Alright, so still kind of acting awkward. Oh, I'm not actually using the spawn position here. So what's happening there is wait, no, that shouldn't be happening. Well, I'm going to do this anyway. This will probably help. Let's just see what it does. I think it's because they're all right on top of the explosion, so they're all choosing to go the same direction. There we go. That's more like we like it. Yeah. I like that the bullets kind of splinter off when they hit things. We're probably not going to keep that, but it looks really cool right now. Alright. Well, that's a good stopping point. So, anyway, this is the start of a dual-stick shooter. We'll do a couple more episodes on this one and try and make it more interesting, add more enemy types, add some rooms, different things like that. Actually make it into a cool little prototype. So, thank you for joining us tonight. And if you have any questions, concerns, comments, etc., give me an email at why is my why is it not giving this? Hold on, just give me 1 second here. Where is text? Why is my text not showing up? Well, that's stupid. Oh, what am I doing? I didn't want to do that. Alright, well, my text stuff is messed up for right now. So, anyway, Pushy Pixels at pushypixels.com. That's PUSHYPIXELS at P, the same thing. Just do that twice, whatever I said the first time, because I can't believe I said it that well. And that's a .com at the end somewhere. And, buy Proton Pulse or download the free version. And again, I'm going to say that there's a free version coming out for Android, but I just have been too busy. Anyway, thank you guys for joining me, and good night.